Can everyone hear me? Okay, good stuff. So I'm going to talk to you today about Beginner's Guide to Mulesoft. I'm just going to run through the different tools that they give you to start building out APIs and designing them. So, a little bit about me. I'm Parkin. I'm working at Sapient i7. I've been working there for almost a year now as technical lead, and I've got a few certifications. The two that we're going to be talking about today are Mulesoft, Architect and Developer. So what we're going to run through is what is an API, what Mulesoft's vision is for how they want us to build APIs, how we can then design APIs inside of Mulesoft, and how we can build them. And then eventually we're going to move on to, once you've built them, how can you gain value from the APIs that you've built. So, first question, first slide. What is an API? Anyone know what API stands for? Boom, there we go. Application Programming Interface. So you notice in there, it doesn't say anything about it being over the internet or anything else like that. It's just a way to interact with a program. That is all that means. So why REST? So I'm going to be talking to you today about REST APIs and why would we choose REST? So it's very lightweight protocol that you can use over HTTP, and it gives you a whole load of stuff out the box, which is useful. So you've got all the verbs, you've got post, patch, put, delete, get, and those all come out with as a standard, so you don't have to do anything for that. It's just nice and easy there. And you get the status codes back. So the 200 to say everything's okay, 300 for a redirect, 400, you've done something wrong, 500, we've done something wrong. So all of that is out the box. Nice little picture. So just because something's over REST doesn't mean that it's RESTful. RESTful is a way of designing APIs so that you use nouns to describe the object that you're trying to get. And then you use the verbs that we talked about earlier, so delete, post, put, to access those objects. And it'd normally be the name of the collection that you're looking at, so accounts, and then an ID after the slash to say, we're getting this account from the collection of IDs, from the collection of accounts. And then if you want to go further on that, that'll be then related objects to that. So then you go contacts after that, the ID of the account, to get those related contacts to the account that you're looking at. So, Mulesoft's vision. We see three different layers here. So this is what Mulesoft want us to do when we're building our API-led connectivity. We've got, at the bottom, we've got our system APIs. Middle layer, we've got our process APIs. And then on the top, we've got our experience APIs. So right at the bottom of this screen here, you can see a whole load of different systems. We've got databases, web services, a whole load of stuff. Above them, you can also see that there's a load of different shapes. So those shapes are showing you that the way that you interact with these systems is all different, and you have to know something about them to be able to connect with them, right? So it becomes a bit hard to work with all of those systems all at once. So that's where our system APIs come in. We have, working on our system APIs, we have our application owners. So these are the people that understand the system that we're connecting to very well, and they can bring that information out of the system and put it into our system API. So at the top of here, you can see all of our system APIs look exactly the same. So what we do is we build a contract against the system APIs so that everything, when you're accessing accounts, is the same across all of those systems. Yeah. And the way that Mulesoft want you to do this is a bottom-up approach rather than a top-down approach. So that is, when you start working, you choose the project that you're working on, and you choose the fields and the objects that are useful to you, that you're going to gain value from. Rather than trying to look at all of your systems, figure out a whole contract that works for everything across all of your systems, like you used to do with SOA. Don't do that. Work in manageable pieces. It allows you to work quicker and get the project off the ground a lot faster. So that's our system API layer. We then step up to our process APIs, and inside of here is where we do our orchestration. This is where the actual useful stuff comes in. This is where the logic comes in to connect all of your systems together and say, we've got accounts in Salesforce, but we've also got them in SAP. Inside of here, we'll be mashing those two together from our system APIs. Yeah. And then above that, we've got our experience APIs, which lets all of that out to your smartwatch, your phone, your car, even your washing machine. I don't know. Does that? Okay, yeah. But that's then your experience layer, just to surface that information in a way that's the same. So how does this help? How does this make it easier for me, better for me? I don't know. So what this means is that all of your devices, when they're calling an API, they're all getting the same information from the bottom layer of the system API. So it's all going to be exactly the same. Have you ever been stood at like a train station and you look up on the thing and it goes, train's cancelled? You go, train's cancelled? My phone? No, it's saying it's in a minute. And you get the two different bits of information there. It causes a bad user experience. And that's because it's not being pulled from the same source of truth. If you have those pulling from the same APIs, that'll give you the same information back. So why? How is it different? So each of these APIs, we're saying they're modular and reusable. When you put them up onto the exchange inside of Mulesoft, they then become searchable, and it makes it easier for people to be able to use. So, using system APIs, how does that make it easy? Inside of here, we've got a scatter gather. So this is a process API, let's say. We can see that we're calling three different system APIs, one for Salesforce, one for SAP, and one for MySQL. If we decide that our database, our MySQL one, we're not using that anymore, we're using something else, we can just take that API out, that system API, and drop in the new system API that we want to work from. And then it'll pick up that information without you having to do anything else, because they are all using the same contract. So how do we design an API with Mulesoft? Sorry. We've got RAML and OAS, so Open API Specification. If you're used to writing APIs in that, specifications in that, then you can import those in, and that will work with Mulesoft as well. But what they've developed, and is now an open standard of its own, is RAML. So this is the restful API modeling language. And the way that this is superior, I think, to OAS is it's really easy to read. So when you're looking at it, it uses white space to define, like, make differences rather than having everything inside of curly brackets and it looks like JSON. It's a lot easier to read because you can see here's space, so that means it's indented, it's on the next level of my endpoint, and it becomes a lot easier to read and work with. Anypoint Platform Design Center. So this is what Mulesoft give you to start designing your APIs inside of. What they have is a visual editor, which suggests what you might be trying to write, and it's very useful. It will also come up and tell you if there's something wrong with what you've written, and yeah, it's very good. It's a lot better than trying to do it inside the studio. That's not so good. They also provide a mocking service. So once you've designed your API, you can turn the mocking service on, and it will start running as if the API has been built, even though all you've done is design it. So what this means is the moment that you've designed your API and you know what your API is going to look like, you can turn on the mocking service, give that URL to your other developers that are working maybe on your process level, even though you're working on the system level, and they can start working at it. They'll receive back example data rather than real data, but they can start working at it knowing what that API is going to return, which increases your speed of development because you can work in parallel rather than having to wait for that team to finish what they're building. You're just running it at the same time. And as I said before, keep it restful. So let's jump in and have a look into Mulesoft. So this is the Anypoint Design Center. Is this big enough for everyone? Do I need to make it bigger? So I'm going into the Design Center now. So we can see that we've got a few different things inside of here. So we've got a Mule application, API specification, and API fragments. So our API fragments is information about the data that we're going to be passing back. You can think of these about this whole load of different stuff, but you can model what your object's going to look like inside of your API fragments. You can say whether or not those are going to be erroring, whether or not it's pageable. All of that sits inside of your API fragments. Then once you've made those, they all roll up into your API specification, which is what that API is going to look like. If we jump in to one of our data types, so Pokemon data types, and we're going to go in and have a look at these Pokemon, we can see that inside my folder, we've got Pokemon Trainer and Trainer's Pokemon, which are all different bits. So go in and have a look here. We can see we've got several different properties. Salesforce ID, Pokemon name, Pokemon number. So that was there from when I was practicing my talk. If we want to add in a new piece now, so example level, which I just removed. At the bottom, which is slightly off screen now, we get all of these suggestions on what we might want to put inside of there. So we can see, oh yeah, is it an integer? Is it a Boolean example? So that gives you your autofill, which I think is very nice. But also, now I've filled this in, you'll notice I've got a red squiggly line under my example. And that's telling me the example that I've made for my data, for my object, is wrong because it's missing the level integer. So this means that when you create your examples to be passed back when someone's going on the mocking service, they're always going to be exactly correct. They're not going to be wrong. And over here, it tells you what it is that you've done wrong. So you should have required property level. Going back, let's jump in and have a look at an actual specification. So this is the specification that I've got for my process API, which effectively just goes out and picks up all of the different systems that I'm working with and shows it out to the user. We can see we're pulling in resource types from before, so they will tell us what response codes we're going to receive back. They're going to be 200s, 400s, 201s, 401s, etc. And what that data is going to look like. And then, as we were talking about before, this is in a restful manner. So we've got trainers with the responses and the posts, etc., and what type that's going to look like. And below there, if everyone can see that okay, we've got a success response and a failure, which is built directly into the specification. So you can do this if you want to, or you can pull them out. It becomes a lot harder to read when it's all in line like this, but you can do it like to begin with and then pull it out into your different data structures if you wanted to do that. And then at the bottom, we could see we've then got our URI parameter, which is trainer's ID. And when you're using that, that's just telling you this is the trainer that I'm going to go get. And then under that, the trainer's Pokemon. And the very bottom is how you'd sort of expect to see it, which makes it very succinct. And then you'd be able to go into an API specification, just sit and read that and understand what's going to happen when you call it very quickly. So what we've got on this right-hand side, which I'm going to zoom into, make bigger, is we've got the mocking service that I was talking about earlier. So once you turn this on, down this right-hand side, it's going to give you all of the endpoints that you've written out inside of your YAML file. So we've got our trainers, we've got trainers Pokemon, trainer ID, Pokemon themselves. And if we do a get on here, it will give us our example back as well to show you what that's going to look like, which is very nice and useful. Once you've completed it, you come up to this top right here, which is very, very small, but it says publish to exchange. Once you've published it, anyone inside of your company can go and see the API and start working off it and start developing against that specification. So we've designed it. Now we want to actually build it. So with Mulesoft, it's a design first principle. We always design before we start building anything, but it also makes that step to building a whole lot easier, a whole lot more simple. And I'll show you why coming up. So what does it give you to be allowed to build? So again, we can go back into the design center and we can build out flows. In the flows, they're very simple. They're good for wireframing things, like have them up straight away. Just get them running, show your stakeholders maybe what it's going to look like, but they're not very good at error handling, so I wouldn't use them inside of a production environment. At that point, you should be using the Anypoint Studio. So inside of there, you can build out global error handlers, which will error handle your whole project in exactly the same way, specify different levels of error handling. It's really useful and a good tool, in my opinion. You can then deploy your APIs out once you've built them, and you can deploy to Cloud Hub, which is Mulesoft's own thing, and you have to pay them for so many workers, etc. Or, because the way that it works, you can deploy it onto your own stack of servers that you've got sat in a corner of a room, if you wanted to do that, or into a different cloud environment as well. And all of those deployments will work exactly the same. Well, they will all work together, and you'll all be able to see it from inside of the Anypoint platform. So let's build out our first Mule application. I'm going to give it a wonderful name of a and we're going to select a trigger. So for this one, it's just going to be HTTP listener. So this is listening to the web to have something pass through to it. And then next, we're obviously going to go to Salesforce. This now builds you out a quick and easy flow that is listening to something out on the web and will do something inside of Salesforce. Straight from that. The three things that it creates you is your listener, your transform, and then the operation inside of Salesforce. You can chain more of them on if you want to, but as I said, it's just for wireframing things out. But this data weave component allows you to change how you've had it received in to then change how you need to work with Salesforce to get Salesforce to do what you want Salesforce to do. And once you've done that, you can then deploy it out into the cloud and have it running and working straight away. Probably take you about 10 minutes to configure all of that stuff to have it out there and working. But as I said, that's not going to be production caliber. So then we come to Anypoint Studio. And inside of here, taking our RAML file, which we designed before, we could take that and put that straight into the studio. So this might get a bit small, and I'm sorry for that. But if I go new Mule project and give it a name, specify our RAML, what that's gone and done, assuming I'm on the right one, yeah, is created as a whole load of flows inside of Mulesoft based on our RAML file. So for each of the endpoints that we created, for each of our methods, we now have a flow which is going to go off and do something. So for our get our Pokemon, we've got a mocked up flow inside of there, and you can just start dragging and dropping components into it and start building out what that's going to look like. You also have at the top the API kit router. So what this does very well is it makes sure that all of your requests coming into that API fit the RAML that you've designed before. And then anything that doesn't, it'll start throwing errors at whoever's called the endpoint. So, as I was talking about before, this is a process API, and it's getting from two different databases. One of them is from Salesforce, the bottom very small over there, and one of them is from our database one. So this is up and running at the moment in the cloud. If I go to my process API and click send, it'll return me a list of Pokemon inside of there, and that's based on those two different two different system APIs. It's taken the information from both of them, squished them together, and then returned it from it. So now, say database one, We don't like database 1 anymore. We're moving to database 2. Inside of our process API, all that means is, so our database 2 people have gone off, they've created our system API for database 2. And now, at a process level, all I need to do is say, I don't want database 1 anymore. Let's get rid of database 1. And let's drag in database number 2 over there. And the same method on the bottom. Click save. And then that's it. It's good to deploy. And I deploy that up to, I can either deploy it up to the Anypoint platform, so deploy to Cloud Hub, or I can run this locally to test to make sure that it's working as expected. So if I now just run this, I'm doing this because it's quicker to do this than deploy it up to Cloud Hub. It does take a while. You sit there, you click it, and then we'd all just be waiting 10 minutes for it to deploy. But this is a little bit quicker. It's meant to be a little bit quicker.
Is that a local VM?
Yeah, so this is on my machine, yeah. And we get a little answer at the bottom saying deployed. And now we can see at the top, where we had Charizard before, we've now got Blastoise. So that change is nice, quick, and easy for everyone involved. So how do we've built them, we've deployed it, it's out there for everyone to use. How do we then build value to our APIs? So I've lost my cursor. We can add policies to our APIs to say certain levels of users can only call our APIs 5 times in a minute or a second or something. So our gold tier customers, they can call it 5 times in a second. Our silver tier customers, they can only call it 3 times in a second. And then bronze tier or free tier could then only call it once in a second. But you can set up all of these sorts of rules, and how you want to tier those might be just based on a contract that you already have with your customer, or you could make them pay for an extra level up of working inside of your API. You can then share them. So obviously, if they're just sat there in the corner of a room, no one knows that they're there, it's not very useful. Because if no one's using them, you've wasted a whole amount of time of development, designing, and it's just pointless. So you can share out your APIs. You've got 3 main ways of sharing your APIs. One of them is internally, inside of your own exchange. That allows everyone inside of your company to be able to see what APIs are out there, what they can use, and what they can build on. You then have the global exchange, which is everyone who's got access to Mulesoft, so everyone, can see it and can pull down your API and start working with it. And obviously, you can add tiering to it if you wanted to. The third option is you can set up a portal, which is built on communities. When I went to go watch this talk inside of at the Mulesoft Summit, they were doing a roadmap of the future and what's going to happen. And they went, our portal 2.0. They loaded it up, and I was like, that's a community. But yeah, so you can invite people in, and they can see your APIs, and then you're sort of restricting it based on certain customers that you want to be able to see. see your APIs. And then monitoring your APIs. So you choose the size of your workers, how much CPU they've got, how much RAM they've got. And that might be good for what you first deploy. Like, that might be all right. But then you get a whole load of interest, and people are using them more often and everything, and you need to ramp up. So that's where your monitoring your APIs comes in, because you can get notifications of when it gets close to the limits in your CPU, when it gets close to your RAM limits, etc. So that comes in really, really helpful. And they did mention that in the future, they're going to start building in AI to their monitoring as well. Finally, you can visualize your API network. So this is actually what is happening inside of your APIs that you've built. It isn't how you meant to design them, and that's what you're looking at. It's actually what's happening inside of your APIs. So you can go in and have a look at this after you've designed it, handed it off to your developers to work on. You can come back, see the traffic that's running through those and go, that's wrong. That shouldn't be calling that. You've got direct access straight into one of our system APIs. We need to shut that off. We can't be allowing people to have access to that. So let's go in and have a look at our monitoring as well. Back into the Anypoint platform. And the first one that we're going to look at is our visualizer. So as I was saying, if I put on external traffic here, we see that I've called all of these APIs to just make sure that they're working. But in reality, we wouldn't want that. We wouldn't want to provide access to our process API layer or our system API layer. We'd want to have that all gated through the experience layer to then give access to those APIs so that we know who's calling our system API and process API can be trusted. So if we go in and have a look at what's being called, turn off the external traffic because we know about that, that's fine. We can see that our process API at the top is calling 2 system APIs. And that's right, that's what we want it to do. We can then go into our runtime manager, and this will tell us how our application's working, how our API is working. I'm going to go in and have a look at our process one. When it loads. It's been really quick every other time that I've done this. It's sod's law. There we go. Okay, so inside of here, we get some statistics and nice graphs of what's been happening inside of our process API layer. So we can see there's been more calls at that point over there, or over there, than we've had for the rest of the hour, and you can spread that along those different timelines up there. It also gives you, if you've got it turned on, a nice little logs of everything that's happened inside of there as well, so that you've got an idea of what's happening if something goes wrong. Thank you very much. Any questions?
What's one of the more popular public APIs on your Anypoint platform?
Oh, that's a good question.
Any example?
They've got a whole lot of APIs on there. Yeah, I can't choose a favorite. Sorry.
On the
Yeah.
How is that, if I want to put it out publicly and I want it to provide connected app kiosk, how does that get configured?
Yeah, so you design that again inside of your YAML. You can set up all your security inside of there. But then you have to ensure that that's being enforced in your app as well. Does that answer your question?
I mean, I guess like you had an API which is calling, say, 3 different systems.
Yes.
Calling Salesforce, calling SAP, calling something else. Is the authentication being done by Mulesoft over here, or is it being done by individual systems that are called?
So it depends on how you want to implement it. So you might say that I need authentication at a top level. So at our experience layer, we want to have like a gated access to it. And then everything, once you've gained access to the experience layer, that Mulesoft has access to everything else underneath, but it needs to have had the authentication at that point. Or you can say, I want the person to have access to these different systems to gain that information. It does then limit the information that you're pulling back, so it's probably not advised. But you can do that and then pass the tokens along inside of there if you wanted to. Yeah, so that it's at a per user basis instead.
Can Mulesoft give the identity?
Yes, yeah, it can be. Yeah.
You mentioned logging at the end. Are there any downsides to logging to the
So there will obviously be a little bit over the top, but it's not. I don't think it's enough to worry about. Okay, if that's all. Thank you very much.
Capado separates user stories into individual feature branches in your code repository. This makes it easy to deploy code into multiple environments without having to worry about other developers' changes being introduced accidentally. Capado also automates the process of doing a pull request, making it easy to compare code from one environment to the other.
Earlier, with chain sets, adding metadata components used to take time. But with Copado, it has become easy and quick because it provides ability to search, filter by type, last modified by, created date, etc. Also, it has ability to integrate with Jira, Git, Bitbucket, making it powerful and providing traceability for our changes.
As a release manager at MassMutual, the great benefits I see are it helps us to bundle multiple user stories across a team and deploy in one go, which saves a lot of release time. But in chain sets, we have to deploy user stories individually. With chain sets, developer can skip environments while deployment, but with Copado, we have a set deployment flow between the environment. Copado comes with a great reports and dashboard, which helps us to track an org level metadata changes.
When I joined MassMutual approximately a year ago, we had a team size of around 50. Now, over the last year, we've increased probably about twofold, and we've gone over 100 people for this team. Bringing in Copado was one of our best decisions. Not only was it a scalable solution with delivery with high confidence, but it also introduces and integrates the QA piece, establishing a CI/CD pipeline that every company really wants in today's day. They have given us professional support. They have given us innovative solutions. They have really worked with us hand in hand closely to make it a success story for us.
What some people may not realize is that MassMutual has been on Salesforce now for many years. As we leaned into our digital transformation, this presented both a challenge and an automation. This presented both a challenge and an opportunity in terms of maturing our release management practice. I'm actually very pleased with both the features and the partnership Copado has offered. We've achieved a number of short-term wins, and I'm now more confident about our future ability to scale our DevOps practices here at MassMutual.